Hello students, I have already discussed the Coulomb's law. In continuation with Coulomb's law, today I am going to discuss different types of numerical problems based on Coulomb's law. So number one problem is a charge Q is to be divided on two objects. What should be the value of the charges on the objects so that the force between the objects can be maximum? So we have been given a charge Q, and this charge Q is divided into two parts. Let the first part be small q. So the second part will be Q minus Q. Let us suppose that R with a separation between these two charges, then Coulomb's repulsive force between these two charges will be F equal to 1 by 4 pi epsilon naught Q minus Q into Q by R square. For force to be maximum, we will have to differentiate the force with respect to small q. We should take dF by dq equal to 0. As we know that for maximum or minimum, dy by dx is 0. In calculus you will learn. So at this moment we have to consider dF by dq equal to 0. So after differentiating the force with respect to small q, we get small q equal to q by 2. So this is the charge on the first body. To calculate the charge on the second body, we will have to find out the q minus q, and it is q by 2. So charge on both the bodies are same, that is q by 2. Next problem, two point-sized identical spheres carrying charges q1 and q2 on them are separated by a certain distance. The mutual force between them is F. These two are brought in contact and kept at the same separation. Now the force between them is F dash. Then so that F dash by F equal to Q1 plus Q2 whole square by 4Q1 Q2. So in first case, when Q1 and Q2 are separated by R, then Coulomb's repulsive force may be written as F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. In second case, when they are brought in contact, then we just find out the total charge. When they are in contact, the total charge is Q1 plus Q2, and charge always remains conserved. We know that charge can neither be created nor destroyed. So after separation, what will happen? The charge on each object will be Q1 plus Q2 by 2. And now the separation will remain the same according to the question. Then F dash equal to 1 by 4 pi epsilon naught Q1 plus Q2 whole square by 4R square. Now taking the ratio of F dash by F, we will get the required value, that is Q1 plus Q2 whole square by 4 Q1 Q2. F dash by F will give the final result. So in this case, only thing that we should keep in our mind, when they are brought in contact, then we consider the total charge of the system, that is Q1 plus Q2, When they are separated, then charge is divided into two parts, that is Q1 plus Q2 by 2 and Q1 plus Q2 by 2. So the final result we have got by taking the ratio. Now moving towards the third numerical problem. The third problem is completely different from these two. In this problem, a point charge Q is situated at a distance D from one end of a thin conducting rod of length L having charge capital Q which is uniformly distributed along its length. As shown in the figure, find the electric force between the two. So I have drawn the figure on the board. You can see the length of the rod is L and a charge is placed at its separation D from one end of the rod. So to find the force between rod and small q, we will have to consider a small element of the rod of length dx. Since we cannot find the force directly in this case, so first we will consider a small element having charge dq, which is separated at a distance x from charge q. This is the distance between q and the small element. Now there are two charges, small q and dq. We will find the force between these two. Thereafter we will find the net force between the rod and small q. So first of all we will have to find the value of dq. So equating charge per unit length, charge per unit length of the element is dq by dx and charge per unit length of the rod is q by l. So dq equal to q by l dx. Now small differential force between dq and q is given by df equal to 1 by 4 pi epsilon naught q dq by x square, and 1 by 4 pi epsilon naught is replaced by k q by x square q by l dx, because we have given the value of dq. Now this is a small force between a small charge element, length element and charge q. Now to find the total force between rod and charge q, we will have to integrate df within proper limit. So net force F is given by integrating df between the limit d and L plus d. When we integrate the small force df in the proper limit d to L plus d, then we find the total force between these q and the whole rod. So after calculating we are getting the value of force as 1 by 4 pi epsilon naught q by d into L plus d. So up to this point you go through these three numericals, and if you have any doubt you may consult with me. I will give the answer. Thank you.